So here is the pre-quiz part 2, second half. Here are the solutions, so I'll go through it. You can watch it time and time again. Get ready for the quiz on Thursday. Okay, absolute value equation. So this is an equation, right? So that means that there's an equal sign. So we're talking about equation. That means we have an equal sign. Whenever we have absolute value, that means we have two answers, right? Because absolute value is the distance from 0. So if I'm at 0 distance, so I can be positive 6 away, or I could be negative 6 away. Right? 1, 2, 3, 4, 5. One more, 6. Okay. Right? So I could be 6 away or positive 6 away. So that means this could equal the inside of this could be 6 because the absolute value of 6 is 6. Or I could have inside the absolute value negative 6 and I'd still get an answer of 6. So notice that that's why I have two answers here. So there's kind of two ways that you can do it. One way would be to rewrite the equation the exact same, right? Set it equal to 6. And also set it equal to negative 6, right? Because my absolute value could be 6 or my absolute value could be negative 6. And then you could solve these equations and there would be your two answers. So both of these you would add 1 to both sides. 4x equals 7 and 4x equals negative 5 divided by 4. So there's one answer. Divide by 4, there's another. So x is equal to 7/4 and x is equal to negative 5/4. Since it's equal, they're the two answers. So the other way to do it is do basically the same thing, except for instead of doing negative 6, I could rewrite this as negative 4x plus 1 equals a positive 6. So basically I could take the inside of the inequality and change that instead of changing the right side of the equation. But here it really doesn't matter. You just got to be careful. Like on the second one, when there's 2 in there, you really got to change not just the 3x but also the 2. So when we have equalities equal to each other, again you write the first one the exact same, and then here all we have to do is change one side. It doesn't matter which side to change. So change one side. Probably should switch color, but that's okay. And this one I'm going to change not just the 3x to the opposite, but also that positive 2. So it now needs to be negative 2. So there are my two equations. I could have changed the 5x minus 2 to negative 5x plus 2, but just change one of them. So now we solve both of these. I'm going to add 2 to both sides of this one, add 2 to both sides of this one. We get 5x equals negative 3x plus 0. Right? And 5x equals 3x plus 4. Okay, so this on this right one, there's people get confused because there's all there is x's on both sides. So that's fine. Move your x's to one side, add 3x, add 3x. So we get 8x equals still 0. Divide by 8. We can still divide by 8. 8 divided by 0 is still 0. So there's one of our answers. Okay, over here we take 5x, and this time we're going to subtract 3x. And so we get 2x is equal to 4. Divide by 2, divide by 2. So x is equal to 2. And that's our other answer. Okay, absolute value inequalities, that's where it's a little bit different. Okay, so here, again, you write two different equations. One's the first one, and the next one you make one side negative, right? So there's just a little bit difference with inequality. Okay, so I'll write first, basically, if you get the absolute value by itself first, that would probably be a good way to start. That's the way you should start. There's a way that you don't have to, but just do it this way. So get the absolute value equality by itself first, then write your two equations. Okay, then write your two equations. So one equation will be 1 minus 3x is less than or equal to 5. And your other inequality would be, the best thing to do here is I would just change what's inside the absolute value. And so a -1 and a plus 3x is greater than or equal to 5. Whenever the inequality is facing to the opening to the left, it's always greater than. When it's facing to the right, it's always less than. That's how you'll always read it. Excuse me. Okay. Okay, so go ahead, you can solve these two. The only difference with inequalities is just make sure, I like to move my x's so that I can have positive x's, because if you ever, actually this time I won't. If you ever divide by negative, so we have -3x is greater than or equal to 4. Whenever I divide by an x, like on this problem right here I'm going to, you have to flip that inequality. So I have to flip its direction. I don't change the or equal to, it stays or equal to, but I have to flip that direction. So there's one answer. And then this one I go ahead and solve. So 3x is greater than or equal to 6. So my second one is greater than or equal to 3. Oh, I divided by 3, so it's 2. So those are my two answers. And then here I just, well, the other way that you can do it, instead of switching this one and taking that one, I could have wrote it as left 1 minus 3x, like that, and I could have changed the 5 to a -5. But if I change that one like that, basically that means I'm basically multiplying that by a negative, so I would have to flip the sign. So that's why I just change what's inside the absolute value, because then I don't have to flip the sign. But if I change the other side, then I do have to change the sign. And you can see if you solve this that you get that same answer of 2 pointing towards the x here, where this one would be, it would be pointing towards the x, because eventually you'd have to divide by a negative, right? Okay, so another part where this is a little bit different is whenever you have an absolute value, I want you to write your equation in interval notation. Okay, interval notation is just kind of like set notation, but it's just a range of answers rather than one answer, next answer, next answer. It's a range of answers, because our answers can be from less than -4/3 and greater than 2. Okay, so we have a range of answers. That could include 2.3, 2.5, 2.7, 38.2. So we have a range of answers, so we want to list it in interval notation. So I put these answers on a number line. Okay, so I put these answers on a number line. So we have -4/3 and we have 2. And then I can put, since it's or equal to, these would be solid dots here. Okay, and then I pick a number in between. So I pick a number in between these. So between 2 and negative would be 0, right? So unplug 0. I'm going to plug it back into the original. So 1 minus 3 times 0. Take the absolute value of that, then add 2 and see if it's greater than or equal to 7. So we have 3 times 0, 0, 0, 1 minus 0 is 0, or is 1. Absolute value is 1, and 1 plus 2 is 3. So is 3 greater than or equal to 7? Well, that's not true. So that'd be false, right? So since that is false, then that means you could really actually test a point over here and test a point over here, which is good on the next one. But in all actuality, almost all of these will be the same, except for when you have like number 4, which you will have on the quiz. Then all this going this way would be true, and going this way would be true, that's what our inequalities say too. So since our number's going this way, that means we have -infinity. And we always go from left to right, and we keep going until we hit -4/3. And since it's a solid dot, we include it. And then we go from 2, and we do hit it. So it's a bracket. And we go to positive infinity. And then we always put parentheses around -infinity and infinity. And then we join them together with the union. So that's how I want your answers. Okay, I don't want your answers in inequality. I want them in interval notation. Okay, now when you have a problem like number 4, you can solve it the same exact way, but when you test number 4 on a number line, so say you have your 2 answers, when you test 4, you're going to come up right here and test a point, and it's going to be true. So then it'd be everything in between. But it's also true on this side and this side, because if we look at the problem, we notice that it says the absolute value of an expression here is greater than or equal to negative 5. Well, absolute value means that it's positive, right? It's talking about distance from 0, so it's always going to be positive. And a positive is always greater than or equal to a negative, so that's all true. That's always true, no matter what x you plug in. So our answers for number 4 are going to be from negative infinity to positive infinity. And that's how I would want your answers. Okay, so that one you got to be careful about. Look at the statement. If it's true for every number, then it's going to go from negative infinity to positive infinity. If I wrote it like this, absolute value of 12 minus 8x is less than or equal to, or say just less than negative 5, then there's no positive number. Absolute value makes it, after simplify, it makes it positive, right? There's no positive number less than or equal to a negative number. So this would always be false. So there would be no real solution for that one. So make sure on number 4 on your quiz that you pay attention, because it's probably going to be just like this. All right, solve the linear inequality. Again, this is linear, so it's just basic. You can treat it like an equal sign unless you divide by a negative or multiply by a negative. And then here you're going to have an answer. And again, I want the inequality answers in interval notation. Okay, so here we can basically treat it like an equal sign. I like to move the negative x's to one side, so then I just have positive, and then I don't have to move the inequality. But for practice sake, most of you will probably do it this way. So we get negative 3x is less than or equal to 5 plus x. Then we could subtract x on both sides. So then we have negative 4x is less than or equal to 5. And now here I divide by a negative. So since I divided by a negative, that means I need to flip this inequality. Okay, so I need to flip that. Goes the other direction. Okay, so now I could put this on a number line. As long as I flip my inequality correctly, then I should be fine. But say if I messed up or I don't know that, or if I just treated it like an equal sign the whole time, then I would want to test this number, negative 5/4. So I could plug in a number to the right and a number to the left. Again, you probably don't have to plug in both of them. So a number greater than negative would be 0, so I can plug in 0. Negative 3 times 0 is 0. Minus 3 would be negative 3. And negative 3 is less than or equal to 2 plus 0, which is true. Negative 3 is less than or equal to 2. So that's true. So it is everything going this way. If you want to, you could test a point over here. That'd be like negative 2. So negative 2 times negative 3 is 6. 6 minus 3 is 3. 3 is less than or equal to 2, what did I say, negative 2? Which would be 0. And negative 3 is not less than or equal to 0. So this would be false over here. So, and it's true over here. And that's what our inequality says. X is greater than, so all my numbers greater than negative 5/4 or equal to negative 5/4 would be true. So that goes from negative 5/4, and since it's or equal to, that means it needs to be a bracket, and all the way to positive infinity. So that's what I want your answer to be. Okay, another inequality, just make sure on this one you distribute that 3 to both of those. So 6x minus 4x plus 1 is less than 3x plus 12. And then go ahead, simplify, right? So this is 2x plus 1, 3x plus 12. Now go ahead and put your x's to one side. I'm going to move the smaller x's. I always move the smaller x's, because then I deal with positive x's in the end. Let's extend this page. Okay, so we subtract 12. Subtract 12. Get negative 11 is less than x. So now I can test this. So we can put it on a number line, negative 11, it says it right there. Negative 11 is less than x, or you can read it from right to left. X is greater than negative 11. So everything greater than negative 11, I can test it by plugging in, again, zeros on this side. Plug in 0, 0, I get 0, 0, plus 1, so I get 1, and then 0 plus 4 is 4. Is 1 greater than 12? Is 1 less than 12? That's true, so it's true everything this way. So from negative 11 up, it would be true. And am I including negative 11? No, because it is just less than. So I do a parenthesis on this. So that would be my answer to number 6. Okay, now we're to the back page, solving rational inequalities. We have fractions. So here we have inequalities, so I want your answers to be in interval notation. Okay, so here, first things first, whenever you're dividing by something, we need to make sure that x cannot be a certain number that makes the equation on the denominator 0, right? So we take that fact, we set 2x, or 2 plus 3x equal to 0. So set it equals 0, we want to find out what makes the denominator 0. So we subtract 2, 3x equals negative 2 divided by 3 divided by 3. We have x equals negative 2/3. But x cannot be that, right? Because if it is, then I would have 0 in bottom, and that would be undefined. So x cannot be that. So that means when I write my interval notation, I will use an open parenthesis to contain that negative 2/3. Now I'm solving, so now I can just go ahead and solve. So that's one of my answers, you can say. Then I need a second one. So how do I get rid of dividing by 2x plus 3? Well, I multiply by 2 plus 3x, sorry, on both sides. So 2 plus 3x. Okay, so then I have x. These cancel out, which is awesome. No more fractions, right? No more fractions is a happy day. Less than or equal to, multiply, distribute that 3 to both the 2 and the 3x. So you get 6 plus 9x. Then solve for x, all right? I'm going to move this one over here. I like to have positive x's. So we have 4 is less than or equal to 6 plus 10x minus 6 minus 6. So we have negative 2 is less than or equal to 10x. 10x. Oh, well, maybe I should subtract, right? Because 9 minus x, I drew a line over my negative, so I couldn't see this negative right here, is not 10x. It would be 8x. So let's fix that. Okay, 8x, so then I divide by 8 on both sides, and look, I get x is greater than or equal to negative 1/4. I just moved my x, and the alligator is eating the x, so of course it's eating the x on the other side. Okay, so then I have my two answers, right? Negative 2/3 and a negative 1/4. Again, when you have inequalities, it's best to put them on a number line and test them out. So negative 1/4 and negative 2/3. Well, negative 2/3 is negative 0.67 or 66 repeating forever, right? And negative 1/4 is negative 1/4, negative 0.25. So a number in between those to test would be negative 0.5. So that's negative 1/2. So these are really tricky, right? Because I have negative 0.5 plus 4 divided by 2 plus 3 times negative 0.5. Ooh, lots of negatives and lots of decimals. Okay, so this one turns into 0.5. Okay, so this one turns into 3.5, right? Minus 1/2. Oh, let me fix this over here. This is actually a 1/4, right? That's a 4. A 4. Okay, so onward. Then the bottom would be 3 times negative 0.5. That's negative 1.5, so 2 plus negative 1.5. That would be 0.5. So I got 3.5 divided by 0.5. So that equals 7. So is 7 less than or equal to 3? I'm writing on number 8 there, which is not true, right? So that's false here. Oops, false. So that means it's everything going this way. And come on now, and everything going this way. So my answer to this would be, I'm running out of room here. I have to move stuff over. Let's get rid of this. Okay, so it would be from negative infinity until negative 2/3, but it can't be negative 2/3. So we need to put a parenthesis around that. So negative infinity until negative 2/3, parenthesis around that, and then we go from negative 1/4, and it can be that because it's or equal to, correct, up until positive infinity, and then we union it together, and so that is the answer that we have. All right, so now let's move on to the second one. Again, set that equal to 0. The denominator equal to 0. So x cannot be 3, but that's one of our numbers, right? So that's the number that we're going to test. We'll put that here. So we're going to test 3. We don't know if it's going to be left or right there, but that's okay. How do I get rid of dividing by x minus 3? Well, we multiply by x minus 3 on both sides. So I need to distribute that 1, which is not changing anything really. Fraction's now gone. Awesome day. So we have 2 is less than or equal to x minus 3. We can add 3 to both sides. We got x is greater than or equal to 5, or 5 is less than or equal to x. So we have 5 and 3, so we have 5. That's going to be more this way, and 3 is going to be this way. We can test a point in between, which is 4. So we plug in 4 into the original. So we want to test 4. So we take 2 and take 4 minus 3. Is that less than or equal to 1? Which is 2 less than or equal to 1? That's false, right? So that's false. So then we go from negative infinity up until 3, and then from 5 to positive infinity. And then which bracket do we use? It's less than or equal to, so on 5, but it can't be 3, right? It can't be 3, so parentheses, join it together with the union. All right, last two. Here we go. So these are quadratic inequalities. So that means, again, you could treat it like an equal sign, find your two answers, plot your two answers on a number line, test a point in between. If it's true in between, which I don't know if it has been yet, I don't think so, then it's everything in between those numbers. If it's false, then it's everything outside. And we're going to join those two sets to get, or those two intervals with the union. Okay, so it's quadratic. So basically treat it like an equal sign, subtract 15 from both sides. You could do quadratic formula. You could do completing the square, which I wouldn't recommend because your a is not 1. And then you can factor, and this one is factorable. So 3 times negative 15 is negative 45. That's your CA. And then your B would be negative 4. And so that'd be negative 9 and a positive 5. Times those together, I get 45. And then subtract them, right, I get negative 4. So x minus 9 would be one factor, and x plus 5. But since I multiplied c times a, then I have to divide by my a, which is 3. And this is set equal to 0. Divide by 3, so x minus 3. And I want to leave this one as x plus 5/3 because I'm not just factoring, I'm actually solving. So I set each of these equal to 0. That's why I left it like that. So really, all I have to do is say, what minus 3 is 0? Well, that's 3, so that's 1 of your numbers. And then what plus 5/3 is 0? Well, that's just the opposite, right? Negative 5/3. So that's why I left that as a fraction instead of taking that 3 and moving it in front of there. So those are your two numbers. So you have negative 5/3, and then you have positive 3. Test a number in between. Whenever you're doing quadratics, if you could test 0, 0 is really awesome. Because when I throw that back in here, I get 0 squared, which is 0, and 0 times 3 is still 0. And then negative 4 times 0 is 0. So I just get 0 is less than or equal to 15. 0 is really nice to test. And 0 is indeed less than or equal to 15. So nice, we have one in between. So this time it is true, so that's everything in between these. So it goes from negative 5 to, or negative 5/3 to 3. And is it included? Well, it's less than or equal to. So yes, they're both included as answers. So that's number 9. Let's finish off with number 10 here. Again, it's a quadratic. This one is factorable again, but you could use quadratic formula. Let's go ahead and do quadratic formula. It is set equal to 0. So I have my a equals 1. I have my b equals negative 1. And I have my c, which equals negative 12. So here we can go ahead and do quadratic formula. That's negative b plus or minus the square root of b squared minus 4ac all over 2a. So I plug in my b, it's a negative negative, which is going to make a positive, then plus or minus. Make sure when you square root your b squared. Let me just go ahead and circle this and point to that for people that are just looking at the notes. And onward, b squared, my b is negative 1. Make sure when you square a negative, you always get a positive. And then you take negative 4 times your a, which is 1, and times your c, which is negative. So then I have two negatives in here, which is going to make a positive. So you're actually going to be adding there. And then divided by 2a. Let's make some more room down here. Okay, so then we have negative, and negative is a positive 1, plus or minus the square root of negative 1 squared, which is 1. And then negative 4 times a positive 1 times a negative is adding 48. which is awesome because that's 49. So what that means is basically that's factorable, right? Because you have 1 plus or minus the square root of 49. Whenever you actually can solve that square root, basically means that you could have factored it. And so because the square root of 49 is 7, so we have 1 plus or minus 7 over 2. Never leave your answers like this, because whenever you have all three of those terms right there, you can solve it. So please solve it. So 1 plus 7, then divide by 2 is one of your answers, and then 1 minus 7 divided by 2 is the second answer. Again, don't leave it like that. Go ahead and solve it. So this is 4, and this is, what's negative 6 divided by 2 is negative 3. So those are your two numbers. Again, since it's an inequality, put it on the number line. So we have negative 3 and 4. Test a point in between. Awesome. It's 0. 0 is always a great point to test. 0 squared is 0. So 0 squared minus 0. Minus 12 is less than 0. Is it less than 0? Oh, greater than 0. Sorry. Greater than 0, less than 0, I think is the example in your book. So we have negative 12 is greater than 0, which is false, right? So that means it's going to be everything down here and everything up here. So we're going from negative infinity up until negative 3, and then going from 4 to infinity. And then we join them together. Well, first, what is the inequality symbol? It is just greater than, so these are parentheses, and join them together with a union. Boom, there we go. If you wanted to, you could test a point on the outside here and a point on the outside here to make sure it's true, but I'm not worried about that. So there are all your answers. Have fun looking at this and enjoy watching it and listening to my voice, because I know that you love the sound of my voice.